Alrighty, let's get started with lesson 13.3, page 584. We're continuing with graphing linear equations, and today we're going to apply what we learned to write and graph proportional relationships. So ladies and gentlemen, we learned in our last unit what a proportion was. So we're going to graph proportional relationships. Our essential question, how can you describe the graph of the equation y equals mx? Whoa, there's an m in there. What does m represent? You better be saying it to yourself. We're going to talk about it in just a second. So, from the book you could have read, and that would have been fine. You wrote some stuff down. I already printed this whole thing for you. Who knows if you wrote anything. Hopefully we're going to highlight some stuff because it says when two quantities x and y are proportional. Oh my gosh, x and y are proportional. It says the relationship can be represented by the direct variation equation y equals mx. So the first thing you need to make sure you write down in your notes that you have in there. Direct variation equation is y equals mx, where m is the constant of proportionality. Uh-oh. You mean that's another definition for what? Slope. So m, slope, is also constant, see on S-T-A-N-T, of proportionality. Just another definition of slope that we can add to the long list of definitions we put on our last lesson. So m, slope, can also be called the constant or proportionality, rise over run. And we know in a proportion, we have a ratio equal to another ratio. So you write that ratio as a slope of the rise to the run, rise to the run, and they're going to be proportional. Makes only sense. It says the graph of y equals mx plus b is a line with the slope of m. Well, we just said that. We just said slope m is now constant of proportionality when we have a direct variation equation, y equals mx, because we have a proportional relationship. But here's another thing you got to absolutely make sure you know. Passes through the point 0, 0. We call that the origin. It is the origin. 0, 0 is the origin. If you have a proportional relationship, it passes through the origin. If it doesn't pass through the origin, you do not have a proportional relationship. I don't care about anything else. All right? So, ladies and gentlemen, go ahead and put your pens, pencils, everything down. If you want to pause this video later and write anything down, you certainly can. But let's take a look at a real-life graph of a proportional relationship and talk about and understand some things that are going on here. This is the graph of a water tank. It says on the y-axis we got the height in inches, and on the x-axis we had the volume in gallons. And the first thing you can notice about this graph is that it does, in fact, go right through that origin. It goes right through the origin. All right? And now let's take a look at some other parts of this graph. Let's take a look at some of the points on this graph. And we can see we have a point right here at 21. We have another point right here at 40 and 2. We have another point right here at 60 and 3. And we have another point right here at 70 and 4. And if we even wanted to go on, there is a point right there at the end of the point, at the arrow, and that is 100 and, oh, I said 70, it should be 80. Heavens to Troy. That previous point was 80 and 4, and this last point is 105. Okay? So, ladies and gentlemen, we have those points. Now, we talked about the relationship between x and y had to be proportional. So if I come out here and I write a proportion, and I choose any two of those points, I'm going to choose this one right here, 40 and 2, and of course, I'm going to put y on top. Which number is y? That's right. So 2 over 40. And I'm going to choose this one right here. I'm going to choose 105, and so the 5 would go on top, and the 100 would go on bottom. Now, a couple things we can think about. Can we prove it? This is a proportion. Well, on this one, the easiest way to do it, of course, is cross products. 5 times 40 is 200. 2 times 100 is 200. and so this do form a proportion. So this is the graph of a proportional relationship passing through the origin 0, 0. Let's talk about that origin 0, 0. It only makes sense if we don't have any gallons, we don't have any height in inches. You don't have any height if there's nothing in there. It's only logical. Okay? And then let's talk about the slope of this line, counting from one point to another. So we're going to go right here. I'm going to use the purple this time, and I'm going to go up from 1 to 2 and then over from 20 to 40. So I'm going up 1 and I'm going over 20. So the slope of this line is 1 to 20. Let's see if that's true. We took this first point right here. Let's simplify that point, 2 over 40. And if I divide both by 2, I get 1 over 20. And if I come to this 5 over 100 and simplify by dividing by 5, I also get 1 over 20, meaning it's proportional, and that is the slope. That is the slope of this line. For every 20 gallons, the height of this tank rises 1 inch. So we could write the direct variation equation. The number of inches is equal to 120 for the number of gallons. Right? Makes sense? Alrighty, so y equals 120x, where y equals mx, the slope is 1 over 20. Wow. Ladies and gentlemen, a lot of this stuff should start connecting for you. So first thing we're going to do now is we're going to actually graph a proportional relationship. And the situation says the cost y in dollars to rent x video games is represented by y equals 4x. We're going to graph this equation and we're going to interpret the slope. So we already know in this equation y equals 4x, that 4 is in the m position. It's next to the x. So that is the slope. And we're going to understand, what does that mean? All right, so let's go over and make a table, because that's how we've learned how to graph. We're going to make this table, x and y. We have our rule, 4x, so we're going to multiply 4 by the input. And of course, we want to know, is this a proportional relationship? So let's start with 0. Because if it's not, it doesn't go through the origin, it's not a proportional relationship. If I put in 0, 4 times 0, that's right, it's 0. What if I choose to rent 2 video games? 2 times 4, that's 8. What if I want 5 video games? Okay, 5 times 4, that's 20. So I can come over to my graph, and we can label our graph. It says y is the cost in dollars. So cost in dollars is our y-axis. And I'm just going to tell you, it's going to set it out there. Let's just go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay. And then x, rent x video games. So our video games is on our x-axis, video games. And let's just go by 1s on our video games. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alrighty. And let's graph those points that we have. We have our initial one, 0, 0, meaning, hey, if I don't rent any video games, I'm not paying anything. If I rent 2, I'm paying $8. And if I rent 5, I'm paying $20. Boom, right there. And I can draw my line. I'm going to do the best I can freehand here, but you guys have your straight edge. And there's that line. It goes up. Bam. And we want to find out, is this a proportional relationship? I can take these 2 points, 8 over 2. Does that equal to 20 over 5? And 20 over 5 simplifies the 4 over 1. And 8 over 2, well, that simplifies the 4 over 1. That's just like our slope of 4, because if the run is 1, you don't need to write it. Outstanding. So what does that mean? Let's interpret the slope. We're going to interpret our slope of m. Well, our slope of m is equal to 4 over 1. Yeah, we write it as 4 because we don't need to write the 1. All right? But what does that mean? Well, since it's the y-axis, that means we're going up $4. Here at 0, 0, I go up $4 for 1 video because I run 1. So on the y-axis, I go up $4. On the x-axis, I go 1 video game. So to interpret my slope, it is $4 per video game. The easiest way to interpret slope, ladies and gentlemen, is take whatever label is on your y-axis, in this case cost and dollars, and put it over your x-axis, in this case video games, and put it as a unit rate, if you can. If you can't put it as a unit rate, you simplify it as far down as you can go, and voila, you have the interpretation of the slope. Let's move on. We don't want this to be dragging forever. Writing and using a direct variation equation. Ladies and gentlemen, says the daily wage, Y, in dollars, of a factory worker is proportional to the number of parts X assembled in a day. A worker who assembles 250 parts in a day earns $75. All right. First thing we have to remind ourselves, we want to write a direct variation equation. What does that look like? Y equals mx. All we have to do is find the slope. And the slope is our proportional relationship. And it says Y is the wage in dollars and X is the number of parts. So our slope as an interpretation is dollars per part. All we got to do is put in the numbers and simplify. Well, the numbers we have 250 parts and we have $75, right? So we want to simplify that. And if we take and simplify by dividing 75 by 250, you get $0.3 over 1, which as dollars, that's 30 cents. 0.30 over 1 part. So every part you make is $1. So now we can write our equation because we know what our slope is. So Y equals 0.3. We don't need to put that other 0 on it. We know it's money, 30 cents. X, right there. All you have to do is find the slope and plug that slope in to where it is, and you have your direct variation equation. The second question, how much does a worker earn who assembles 300 parts in a day? Okay, well 300 is the number of parts. So if we take our equation, Y equals 0.3x, and we substitute in our number of parts, so Y equals 0.3 times 300, that means Y equals 90. Well, we know what Y is. Y is the number in dollars, so that means $90 is how much the worker earns for assembling 300 parts that day. Ladies and gentlemen, here's your quick write telling whether X and Y are in a proportional relationship. Explain your reasoning. Remember two things. One, you have to have a constant of proportionality. That means it's a slope. It's a line. Two, has to go through the origin. I'll see you in just a few minutes for our second video.